Hello everyone, my name is Michael Haig. I'm a senior threat researcher here at Splunk. Today I'm going to be walking through a little bit about how we can begin to hunt for other protocol handlers very similar to the Follina CVE or MS-MSDT. So we're first going to cover what is CVE 2022-30190, how to simulate other protocol handlers using atomic red team, and then how to find more protocol handlers, and then how to take what we found and apply it to Splunk in identifying protocol handlers being used in your environment today. So what is this CVE 30190 from 2022? It was identified by NAOSec. It was dropped on Twitter. The whole 0-day portion of it here is that it can be delivered via an RTF or doc. When it does execute, it uses the handler of ms-msdt, and it will have directory path traversals in there and whatnot. So it's kind of noisy looking, and this is the portion on the left hand of the screen. And so in this particular case, it was being used to invoke PowerShell with a base 64 encoded command in there. And on the right hand of the screen is the any.run showing the behavior of it. So you'll see Windward, or the Office product, spawning MSDT, which would have this command line, like with PCW diagnostic and things like that. And then upon a successful abuse of it, sdiaghost will spawn any other follow-up command. So if notepad was spawned, or in this case on the screenshot, command.exe, performing task kill and things like that. So that's sort of what this was when it was found by NAOSec, and then to the point of Kevin Beaumont calling it Follina and his blog and everything like that. That's where we're at with this. And so for me, when I saw this, I felt that we can go after it and write a very precise signature or detector for it, but I also was thinking what's going to happen next, and that's where this particular blog comes from, is because I wanted to go after what other ones were out there. And so I knew, working on previous protocol handlers for the atomic test harness stuff, compiled HTML has a couple that it uses, along with MSHTA or MISHTA. And so then Follina comes around and uses ms-msdt. So the simplest way is to say, hey, let's run some different protocol handlers just to get this into our data set. Doesn't even have to be related to MSDT, but let's get this into Splunk. Let's get this data ran so that we can at least, kind of dig through this data a little bit more. So yeah, you can run the T1218-001 in Atomic, 005, and then if you want to generate the file, the actual Word doc, you can use John Hammond's Follina builder, and or if you just want to get this ran on the command line, you can honestly just copy and paste this, drop it in the command prompt. It'll run the same thing that you would be looking for anyway, without having to worry about having Office installed in your range or anything like that. So it's as easy as that. Run those, and then let's see what we get in Splunk, right? So like I mentioned, I wanted to find more protocol handlers, and so this led me to the registry, which is hkey classes root. And I found this on another blog, and I think I modified it a little bit, but this particular query is just get item in the registry. You're pulling out two objects, which is property and PS child name, and we're just looking for URL, or as you see in the screenshot, it's the full property name is URL protocol. But what does this matter? Well, ms-msdt is a URL protocol, which is why it's able to perform this particular 0-day type behavior. I'm not saying all of these are 0 days, but maybe potentially these could be abused in the future. So I'm trying to future-proof my analytics, or at least a analytic to hunt for these things in my environment, so that I know what's out there tomorrow. And so in this particular case, show me all the URL protocols within my system, and then I have it commented out, but you can export this to a CSV. And so then you can also take the inverse. What else is there on my machine that doesn't have URL protocol, but may just be of interest down the road? So same thing, this will hit all of HKey class's root, grab all of their properties, and export that to CSV. And so my spreadsheet that I share in the blog has all of them. It has all the MS dash and the protocol handler dash MS names in there. And mine comes from Server 2016 and Windows 11. And so I ended up deduping those. And that's kind of what we lead to here in a minute. So anyway, another way to look at protocol handlers is a utility called Nearsoft URL Protocol View. And this will show you exactly the same thing, just not using PowerShell, but a very nice GUI utility that will showcase, the command line, which would be like the DLL that's used for that particular handler. And so on the left is your protocol handlers, whether they're enabled or not. And then some of them will show the DLLs and whatnot, but you're able to kind of key off of all this as well. Very powerful little utility, found that useful. So as I mentioned, I took those, I deduped them, I tossed them into a CSV, and this will be showcased in the demo, but basically now we can create a query that hits all of our command line data looking for these protocol handlers being used. It's as simple as just upload it to Splunk, give it a new lookup name, create that definition, and then write your query. So in my case, the query that we ship with security content is a tstats query. It does not call out any particular process name. However, you can filter it down to just command or PowerShell as the process name, or if you want to do parent process name. But the idea is at the end of this query, it's pulling up our lookup, which is Windows Protocol Handlers. It tells it to name that first column as process, and then output the handler and is handler. And we're only looking for the ones that come up as true. So it's only going to fire on the ones that are actually protocol handlers. And so when you run this, and we already have all of our simulated data in here in Splunk, you'll begin to see the different protocol handlers coming up. And so in this case, this is the MSHTA atomic test harness. This is the MS Word from Atomic as well. There's an MS Word protocol handler in here, and all of these will show up. Now remember, HTTPS is a protocol handler, and JavaScript is a handler that is used by MSHTA. So that's why all these show up. Okay, going to now hop right into our demo and start to dig in. Demo, first we're going to use Atomic Red Team to simulate T1218-001 and 005, which is Mishta and CHM. These will both provide multiple protocol handlers for us to go and hunt for using the lookup that we will create, just as we talked about in the blog. So I'm just going to let this run. As that's running, I'm also going to just quickly showcase a little bit more of the utility from Nearsoft, which is the URL protocol view, as things are happening in the background there. But this is the utility that will pull out from the registry all the different protocol handlers out there that are on your local machine. And again, you can see the DLLs that are being called for that, the handler name. As mentioned, there's HTTPS, because obviously that's a URL protocol. And it'll give you a little bit of details. You can dig into each one as well, which is pretty cool. It's nice that it's very just kind of clean and organized, and a nice GUI interface instead of having to dig to the registry or whatnot. All right, so now that these are all kicking off in the background, I'm just gonna let them keep going here. A bunch of calcs and sessions are going to spawn. So yeah, all of that's complete. So that's the first bit. We talked about URL protocol view. I'm gonna go ahead and close that. The next thing I wanna kind of dive into here is using PowerShell to grab all of the URL protocol handlers, which we said that were all pretty much related to MS-MSDT. So again, this is going to go and kick through the HKey class's root, identify other protocol handlers that have URL protocol in them. And so the list is kind of short, a couple errors here and there. So the list is not crazy. That's why I recommend cross-referencing this with a Windows 10 or 11's client. 10 and 11 might have more. It's also going to depend on third-party software that you have installed. Other software will install other handlers. Maybe they're being used, who knows, or just dormant on your endpoints. It's best to know. And if you wanted to go after all the handlers, you want to see what's across your entire fleet, you can definitely add the export to CSV, but in this case, just going to scroll these across the screen. This will dump all of them out. As you can see, there's a bajillion. So that's why I created a quick spreadsheet, kind of mostly highlighting like the MS dash handlers, all of them from Server 2016, Windows 11, all of them from Windows 11 that have the URL property, or the post of the final with the dash MS at the end. There's some that end in that. And then the final is just the dedupe. This is the one that I used for a actual lookup, which we have in Splunk. And as shown on the slides, it's just simple as just calling that lookup, pulling it out, renaming handler as process, and then the query runs across all the command line. And in our case, because we just ran a bunch of the CHM and Mishta, it's as simple as just running this, and it'll go and find all like the JavaScript handler, about, if there's HTTPS, if it's calling out to the internet or has it on the command line, you'll be able to see all of that, which is very powerful when you want to just go and hunt for what's in your environment, what's being used out there. And if you were to baseline like your standard clients in your org, you might find software that's using different handlers that are obviously not in my base one. So you'd want to add those to your lookup and just monitor for them. Maybe they're never used, maybe they're used heavily, either filter it, or if it's something that's never used, maybe set it as a notable to go and track later on, or run weekly in a report just to kind of see what's being used in your environment. So that concludes our demo. We used Atomic to simulate Mishta and CHM file execution. And then to quickly kind of go through, just using our protocol handler lookup to dig through and find what these look like. And again, it pulls it out in the column, so you're able to see those. So, all right, awesome. Happy hunting. Thank you for listening. I hope you found this useful.